Okay, so I have just revised the entire hydrogen burning scenario, right? And what we have here is basically the fact that hydrogen burning can happen by two very different processes. The first one, which is important, is PP1 chain sort of reaction. Now, before I talk about this hydrogen burning, let me talk about something quite similar to this in our real life. Say for example, when a student gives a class 9 examination, then after that what? He has to give class 10 examination, right? And then after your class 10 examination, when the student is in class 11, after successfully passing class 11, then he is offered three particular fields: arts, commerce, science. And we are here because we have chosen science, right? Now this is the same thing over here. So think of it as a student in his school education. So previously he was in class 9, class 10, and then this is something like class 10. After that he is in class, after successfully class 10, he is in class 11, and now he has got more choices. Later on in his life, suppose he chooses science as one of his subjects, then there is a possibility that he can choose physics, he can choose chemistry, he can choose biology, many different fields of science, right? So quite similar to that, there is this thing which is happening over here. Now if I first consider the star, it doesn't have anything like carbon, nitrogen, oxygen or something, anything, just hydrogen is there. And then what we will have, we will just be thinking about hydrogen fusion. So we will just talk about this PP1 chain reaction. So what is that? Basically, this is the set of PP1 reaction. So basically two protons fusing to form deuteron. Next, after sufficient amount of deuteron is produced, then this deuteron, after it is sufficiently produced, remember, not just one deuteron is produced, it will react. There is a possibility. So after sufficient amount of deuteron is produced, then it will again interact with large number of protons in the star, and then 3 helium will be produced. Now after that, the simplest possibility is 3 helium. Again, after a large number of 3 helium is produced, then 2-3 helium nuclei, they will fuse and 4 helium will be formed. Now this thing will process, so on and so forth and so forth. As a result, a large number of 3 helium nuclei will be there in the core along with your 3 helium and 4 helium, both will be there. Now, in that case, another possibility starts, which is this case. So after we have got, here we just have 3 helium, and now using PP1 chain, 4 helium is produced. Now after both these 3 helium and 4 helium population, it builds up, then we can have 1 3 helium nuclei fusing with 1 4 helium. This is a possibility, and this starts another 2 particular chains. They can form 7 beryllium. Now this 7 beryllium can either go and either form again your helium using this 7 lithium by forming this 7 lithium, or it can just form 8 boron and then 8 beryllium, and finally through these chains we will we will basically having production of 4 helium. So you see, just like a class 10 student basically choosing different disciplines and going on and going forth, he is given more and more choices. So here also similarly, more and more choices are there. Now this is the PP chain reaction. There is another possibility which I have shown over here in this part of the diagram, which is Cno cycle. Now for this Cno cycle of hydrogen burning, what we need are these 3 components. Basically, presence of carbon, nitrogen, oxygen in sufficient amount in the core, and they will act as catalyst, just like in chemical reactions also. Now how can we have carbon, nitrogen and oxygen in a star? Either first case, there is no such a thing in a star, but there is a violent explosion somewhere near the star, and because of which a large number of heavy elements have fused inside the star. This is one possibility. Another is during the course of stellar evolution, several elements are formed, and then there is mixing by convection. So it can happen that in the hydrogen shell burning scenario, when the core is inside is say helium and carbon and so on, but hydrogen burning is forming in the shell, then there through convection and mixing, some carbon, nitrogen, oxygens are in that shell, and there this set of reactions can start. And what is basically happening, you can see it starts from here, 12 carbon plus proton forming 13 nitrogen. Next 13 nitrogen decaying to 13 carbon. Next 13 carbon again reacting with proton forming 14 nitrogen. You see, these are the set of reactions. Ultimately this set is 15 nitrogen plus proton forming 12 carbon and your alpha particle 4 helium. And so we get back our 12 carbon. That's why it is called a cycle. Now this is a Cno cycle 1, Cno1, this cycle. Now there is another possibility, which is that suppose this last set fails to form this 12 carbon plus alpha particle. Then what will happen is that instead of producing this, it can produce this set, 16 oxygen. Then again, through this set of reactions, after some time, obviously, through this complicated set, we will get back 14 nitrogen plus 4 helium. And this 14 nitrogen, this will be feeding to this level. So we have got second cycle. This is known as Cno cycle. Okay, Cno1, Cno2. And the end result in both cases is the same, production of helium nuclei. Okay, now here you can also see the energies released from each such reaction, 26 MeV, 20 approximately 26, again 26 MeV. This is little bit lower, 20 MeV, and for this case we have energy released around 25 MeV. Okay, another thing you remember in our last week's lecture, we talked about the temperature dependence of the nuclear reaction rate. There I already showed you that the energy generation rate for PP chain, it varies as T to the power 4. Okay, and what about Cno cycle? It varies as T to the power 19. So they have got very different temperature dependencies. Any questions?